Let's look at graphing the absolute value. Suppose you have a parent function, f of x is equal to the absolute value of x. If you have y is equal to the absolute value of x plus d, that is going to be a shift up when d is positive and a shift down when d is negative. When you have y as the absolute value of x minus c, that is a shift to the right when c is positive and a shift to the left when c is negative. Remember, this is going to be a little bit, it's going to seem like it's backwards. It's really not, though. When you have a times the absolute value of x and a is greater than 1, the absolute value of a is greater than 1, then you're going to have a vertical stretch. When the absolute value of a is between 0 and 1, you're going to have a compression or a shrink. And of course, when a is less than 0, you're going to have a reflection across the x-axis. Now, it's really pretty hard to tell with just straight absolute values when you move b inside and you're not adding anything to it. But when b is greater than 1, the absolute value of b is greater than 1, we're going to call that a horizontal compression. And when b is between 0 and 1, when its absolute value is between 0 and 1, we're going to have a horizontal stretch. And when b is negative, that's a reflection across the y-axis. Now, let's look at some of these. This is a straightforward absolute value of x. I'm going to leave it there. Now, when I move the a and make a larger, this is our vertical stretch, and it makes the opening more narrow, just like it did on the general function. When a is between 0 and 1, it's a vertical shrink. And when a is less than 1, it's a reflection across the x-axis. Let's get this back to 1. When b is 1, let's watch the vertical or the horizontal shrink. All right, that's a horizontal shrink. And when b is between 0 and 1, it's a horizontal stretch. And you really can't see it when b is negative because the points are, because of the symmetry of the absolute value function. Now c, when I move c to the right, when c is positive, so I have x minus c, that's going to move the entire function to the right. And when c is negative, it moves it to the left. All right. And d is the vertical shift up and down. Up when d is positive, down when d is negative. So some random function, okay, you can see you have all of these weird things you can do to the absolute value function. Let's do a couple of problems. What I'm going to want you to do is to put the absolute value function in the vertex form, where the vertex is hk, and you can just read it off when you have y is equal to a times the absolute value of x minus h plus k. You'll be able to see the slope of the line. You'll be able to see whether it's a stretch, a reflection, or a shrink. Your line of symmetry will be at x equals h. So let's look at this graph right here. And I tell you the vertex of the graph is what? Well, the vertex is where these two lines meet. So the vertex is at 1, 6. So h is 1 and k is 6. I'm going to substitute these into the general formula. G is equal to a, x minus h, so I'm going to have 1 there, plus k. Now we're going to use the second labeled point to find the rest of G. So the second labeled point is 0, 3. All right, you're always going to need another point to find this A. So this becomes a x minus 1, absolute value, plus 6. Now I'm going to put this point 0, 3 into the equation. So this is x, this is y. So 3 is equal to a times the absolute value, x is 0, minus 1 plus 6. So I need to simplify this. 3 comes down. There's nothing I can do with that. I combine the 0 and -1, and I get -1. So the absolute value of -1 is just 1. I'm going to subtract 6 from both sides. So when I subtract 6 from both sides, I get -3. So my function g of x is -3 times the absolute value of x minus 1 plus 6. And if I read this off, I see the vertex is at -1, positive 1, 6. And this first branch is going to have a slope of -3. My axis of symmetry is x equal to 1. Suppose I give you this function. I've got 2 points. The vertex here is at -5, -1. And I have another point here at 0, 9. So I can find the slope. The slope is rise over run. So I'm going to go from -1 to 9 is 10, divided by the run, which is -5 to 0, so that's positive 5. So I have a slope of 2. So my formula is y is equal to the absolute value of x minus h plus k. Now here is the slope. So this is going to be 2 to the absolute value of x minus -5 plus a -1. So let me simplify this a little bit. This is going to be 2 times the absolute value of x plus 5 minus 1. The line of symmetry is right here, and it's located at x equals -1. Oh, excuse me, x equals -5. Sorry about that. The y-intercept is actually from the graph, and that's at 0, 9. To find the x-intercept, you would need to set y equal to 0. That's going to take a little work. So 0 is equal to 2 times the absolute value of x plus 5 minus 1. So I add 1 to both sides. So 1 is 2 times the absolute value of x plus 5. Now I'm going to divide through by 2. So 1/2 is the absolute value of x plus 5. Now remember, I have to do this twice. So x plus 5 is 1/2, or, I'll do it over here, x plus 5 is minus 1/2. So in this case, x is minus 4.5, or in this case, x is minus 5.5. So my x-intercepts are going to be minus 4.50 and minus 5.50.